so 2-1 today. What I would like you to do is start off by labeling this triangle in the same way that I am. So go ahead and throw in a right angle right there. And then we're going to label this triangle A, B, and then the right angle we'll label it C. So I don't know if you recall this from geometry or not, but when I'm referring to the sides of a triangle, I could either call this side AB, or in this case it is the hypotenuse because it just so happens to be across from the 90-degree angle, but you can also refer to it as lowercase c, whatever side is opposite the angle. So the same thing here, this would be side lowercase b, and this would be side lowercase a. So if you use lowercase, that refers to a side across from the angle of the same name with a capital letter. Okay? So let's just recap. If we wanted to find the sine of angle A, that would be what over what? What's the magic word again? That helps us remember all this? SOHCAHTOA, yeah. So sine is opposite over hypotenuse, right? So if I'm looking at angle A, opposite side would be lowercase a over the hypotenuse, c. Right? Old news? Try cosine, same thing. Still of A, that's adjacent over hypotenuse. So wouldn't that be B over C? Right? And then tangent, opposite over adjacent. Did you say A over B? Now, you already know cosecant. You do have that chart, but you don't need it. Cosecant would just be C over A, because remember, these guys are reciprocals of each other. So that means secant is just C over B, and cotangent B over A. Okay, you with me so far? Now, I kind of want to ignore what the example says. I don't really want to do that. I'm going to make up my own. In this one, I'm going to do the same thing. I'm going to set up the triangle the exact same way. A, B, C, little a, little b, little c. But this time, I want to find the 6 functions not for angle A anymore, but for angle B. So let's find sine of B. Let's start there. So now if I'm talking about angle B, what would the sine of angle B be? Remember, that's opposite over hypotenuse. So for angle B, what is that? B over C. Does everybody see that? Opposite would be B, hypotenuse is C. So B over C. Okay, let's do cosine of B. Cosine of B would be A over C. And then tangent, let's see, opposite over adjacent would be B over A. And then I can do the same thing. Cosecant of B, I'm just going to do reciprocal of that. So that's C over B. Secant of B, C over A. And cotangent of B, A over B. Okay, so what's the deal with angles A and B? Let's start there. What must A and B, what are they to each other? Do they have any relationship with each other? There is a vocab word that we use to describe their relationship. Okay, let's go back a step further. What must the angles in a triangle add up to be? 180, always, right? And if I have a right triangle, one of the angles has to be 90, right? So what does that mean that A and B have to add up to? They have to add up to 90 together, right? So what's that vocab word for angles that add up to be 90? Yes. Angles A and B have to be complements of each other. Have to be. Otherwise, I don't even have a right triangle. Okay? So that's cool. That's good to remember. Now, if you take a look at the 6 up here for A and the 6 down here for B, well, my goodness, don't we notice some similarities here? Look right here. Sine of A is A over C. Who else is A over C? Cosine of B is also A over C. So you mean to tell me that these two things are equal to each other? They are. That's what we refer to as cofunctions. So basically, look at that. Sine of one angle is equal to cosine of the other angle. But doesn't it make sense? Because think about what A and C are. They're just two sides of the triangle. Right? So when I did sine of A, that was opposite over hypotenuse. But when I'm doing cosine of B, that's adjacent over hypotenuse. I still get A over C, no matter which one I'm doing. So if I had actual values in here, so if, I don't know, if A were a 50-degree angle and then B were a 40-degree angle, that means that the sine of 50 and the cosine of 40 have to be equal to each other. That's so interesting. Who else is the same besides sine and cosine? Yes. So take a look at the tangents are interesting, right? So tangent of A was A over B. Cotangent of B is A over B. So that means the tangent of one angle and the cotangent of the other are going to be the same as each other. Oh, that's interesting. And then same thing happens with the other ones, right? Tangent of B and cotangent of A. They're both B over A. So those are going to be a pair that are going to be the same. And then I have the same things going on. You need something? I guess not. I have the same thing going on with the B over C's, cosine of A and sine of B, right? And then I have the same thing with the reciprocal ones too. So those pairs are going to end up matching up. Oh wait, who's C over A? Oh yeah, secant and cosecant are going to be a pair, and then cosecant, yep, those are going to be a pair. So let's list our cofunction pairs. Okay, so sine of A and cosine of B are always going to be the same as each other. So they are referred to as cofunctions. So maybe we could write that out. Cofunctions equal each other. So there's one pair. Another pair will be tangent and cotangent. And then the third pair are the reciprocal guys, the cosecant and the secant. And you can swap A and B around in any of these, right? Sine B and cosine of A, still a cofunction pair. So let's note that. Oh, I guess we didn't need to write it there because this little side note, I say it right here. Cofunction identities for any acute angle A, cofunction values of complementary angles are equal. Okay, so let's put some numbers in there. So for example, if the measure of angle A is 75 degrees, so what would the measure of angle B have to be? If A is 75, B must be 15. Okay. So now I can say the sine of 75 must equal what? Who's the cofunction of sine? Okay, I'll do this one, then you try the next one. Sine of 75 has to equal the cosine of 15. So these need to be a cofunction pair. Who are our cofunction pairs? These three. Sine, cosine, tangent, cotangent, cosecant, secant. Those are my pairs. These two numbers have to be complementary. Okay? So let's try another one. Let's say tangent of 75 would have to equal what? Well, who's the cofunction pair with tangent? Cotangent. And it would have to be of 15. These two have to be a cofunction pair. These two have to be complementary. And one more. Say I did cosecant of 75 would have to equal secant of 15. Does that kind of make sense? A little bit? Okay. So now this next example, they want you to write these in terms of their cofunctions. How interesting. Okay. Sine of 9. First you ask yourself, well, who's the cofunction pair with sine? It's cosine. And then the number just has to be complementary to 9. So that means it's got to be 81. You see? Look at you guys doing so well. Okay, you try cotangent 76. So cotangent and tangent are the pairs, and it'd be tangent of 14. Cosecant, secant of 45. Yes. Is this all right? A little weird, but once you get the hang of it, it's not so bad. Oh, geez. Look at example 3. Algebra? Really? In math class? Well, remember the rule. These two are a cofunction pair. Yep. Cotangent, tangent, they are a cofunction pair, right. So then what's supposed to be up with these? They have to be these two numbers. This, what's in these parentheses just represents a number, right? So back up here, how'd you all get 81? You got it so quickly. If that was a 9, how'd you know that was 81? They have to equal 90. So look, if this really is going to be equal, that means this thing and this thing have to add up to be 90, because they have to be complements of each other. That's a cofunction pair. That's already established. But now I need these things. Basically, remember what that is. That circle with the line through it. Remember, that's just the fancy variable that we use for an angle. It's like an x, right? So if it was x minus 8 and 4x plus 13, it's this. You operate the exact same way. It's just a different letter. That's all. Okay? So what I need to do is I don't set those equal to each other, because look, 9 and 81 are certainly not equal to each other, are they? No. The only time they happen to be equal to each other is if it happens to be 45 and 45. But that's not going to happen most of the time. What is going to happen all of the time is that these two numbers are going to add together to be 90. Right? Because they have to be complements of each other. So to solve this problem, I do theta minus 8 plus 4 theta plus 13 has to equal 90. Remember, ladies and gentlemen, that theta is literally just like an x. So if those were x's, if it was x and 4x, wouldn't I just get 5x? But it's not x, it's a theta, so I just write a theta instead. Negative 8 and 13 is, what, 5? I went out to dinner with some friends over break, and of course they make me do the tip, and I'm like, hey, I am on vacation. I am not doing any math. It was funny to me. What's 85 divided by 5 is what, 17? Is that right? Or am I just making that up? 15? I don't know. Is it 15? It is. No, it's not. Yes, it is. I don't know. I can't find a calculator. It's right. Right? Or no? 17? Was it 17? 85 divided by 5. Oh. See? That's all I gotta do. So, all I need to remember is that, okay, as long as I have a cofunction pair, yes, I do, secant, cosecant, these two have to have a sum of 90 together. So you try B, and let's see if we can make it happen. Okay, have we got a value? Hopefully. So remember, cofunction pair, yeah, got it, check. These two are supposed to be complementary. So I should be able to say 5 theta plus 14 plus 2, excuse me, 2 theta minus 8 should get me to 90. And now I just have to solve this equation. Remember, thetas and x is the same thing. So 5 of these and 2 of these are 7 of these. 14 and negative 8 is 6. So 7 of these equals 84. That's 12? Yes. So my mystery angle must be 12 degrees. Does that make sense, you guys? Everybody's okay? All right. All right, in the next section, it's, true or false. Those are so easy, right? Well, they are if you remember some things from your trig table project. Let's see if you recall. I'm just going to make a little diagram for myself over here. So we were looking at measures of angles as big as 90, well, almost 90, all the way down to 0, right? As the angles got bigger, this was one of the questions you were supposed to answer. So we started with a 5-degree angle, then you did 15, and so on and so on and so on, and kept getting bigger, bigger, bigger. As the angles got bigger, what happened to sine? Do you remember? As sine got bigger, what happened to the sine? I mean, as the angle got bigger, what happened to sine? Yeah, sine actually gets bigger. So, as theta increased, sine and tangent, remember those two kind of went together? Sine and tangent increase. But it was cosine that starts big and then comes back down. Cosine decreased. All right, so let's just try this. If we do, oops. All right, so let's look at the very first one. They're asking us to compare the tangent of 25 and the tangent of 23. They're saying that the tangent of 25 would be smaller than the tangent of 23. Well, we just said as the angle increases, sine and tangent should increase. So my angle, so that means obviously if it goes down, then it should be going down, right? So my angle went down, the value should go down. So is this a true or a false statement? That's false. The sine of 25 is going to be bigger than the sine of 23. Tangent, sorry. Tangent of 25 has to be bigger than the tangent of 23. Because the bigger the angle, the bigger the tangent. Smaller the angle, the smaller the tangent. Okay, now, this B is talking about cosecant. Well, cosecant, we didn't even talk about at all in our project. We only talk about sine, cosine, and tangent. Oh, but wait. Cosecant. Isn't that just the reciprocal of someone? It's the reciprocal of sine, right? Right? So let's think about this. This is the same thing as 1 over sine of 44. And this would be 1 over the sine of 40. So let's think about this. Sine of 44 should be bigger than the sine of 40, right? Because the bigger the angle, the bigger the sine. So if I do 1 divided by a bigger number, how does that compare to 1 divided by a smaller number? Who ends up being bigger? So this bottom part is big. This bottom part is small. Use actual numbers. So let's say this is obviously totally not the right numbers because I'm just making this up. But if I put a bigger number here, like 1/3, and a smaller number here, like 1/2, who's bigger? This guy is, right? So, is this true? Yes, that is true. Now, let's look at this guy. Well, how in the world am I supposed to compare these two? They're not even the same. One's sine and one's cosine. By golly, wait. Weren't we just talking about sine and cosine being a cofunction pair? And by George, look, 30 and 60. Aren't those complementary? So don't you know right now if this is true or false? What is it? It's false because they are equal. They're actually equal to each other, right? Sine of 30 and the cosine of 60 are equal to each other. So that guy can't be less. So that is false. I'll even add they are equal. Now, I would love for you to reason your way through all of these, but I'm also realistic. You do have access to a calculator. So if you were ever in doubt, you could just whip out your calculator and find the tangent of 25 and the tangent of 23 and compare them without having to stop and think, okay, what's happening with tangent as theta increases? I would love for you to do that, but don't forget to use your resources as available to you. All right. Yeah, and then on the back, all we have to do is, let's just fill in our special right triangles. I know we already know them, but actually this would be a good time for you to see if you have them down from memory. So the first one, this should be the 30, this should be the 60, and these are obviously 45s over here. So let's start with the 45, 45, 90. Remember that the legs are going to be, what do you put for the legs? X. They're both X. And then go ahead and fill in what the hypotenuse is. Don't say it out loud. Just see if you remember it from your brain. What must this be? And then over here, who do you call X over here? Does it matter? Oh, you bet it matters. Which one of these do you label as X? How do you know which is the small side? Yes! The angle opposite the 30 is always the short side that we label X. And then go ahead and see if you can fill in those other two sides. We've had a nice long break, so if you know it now, that means you probably really know it. Okay, you put in the pieces. So this thing right here should be x root 2. Yes, here. That side's x, and then I always do the hypotenuse next. If that's x, this is 2x, and then this weird side is? Yes, x root 3. Double check yourself and make sure that you have that correct. Okay? This side is always the root 2 because it has two sides the same. This side's the root 3. All three sides are different. Okay, good. So we have that down. And then I do want to fill in this chart. Now, I'm pretty sure that you have this chart or something equivalent to it on your reference sheet. However, it is very helpful to sort of be able to know where all these numbers are coming from. Okay? So, let's just take a look at the first one. If I do sine of 30, right? So let's look up here. Sine is opposite over hypotenuse. Opposite over hypotenuse. Wouldn't that be x over 2x? But what does that become if you simplify that? What's x over 2x really? Thank you, 1/2. Don't the x's just cancel? They do. So hold on now. You have a whole bunch of other information before you do any other math. You can fill in other boxes. Now that I know that sine of 30 is 1/2, what other box do I know? I claim you know 2 other boxes. 3 other boxes! Oh my gosh. Yes, cosecant, right? It's reciprocal. If that's 1/2, that means that cosecant has to be 2. I agree. Without doing any other math, you know 2 more boxes. Who has to be the same as sine of 30? Not in, so maybe I'm misleading. You don't know any other ones in this row, but in the whole chart you know two more. Who has to be the same as sine of 30? Cosine of 60. Because they are cofunctions. So you're a half. And so if that's a half, then I also know secant has to be 2. Because they're reciprocals, right? Cool. All right. Look at that. So now let's try cosine of 30 maybe. Cosine of 30 would be adjacent over hypotenuse. So that would be x root 3 over 2x. But if you simplify that, what's x root 3 over 2x become? Root 3 over 2. Great. So I have cosine, so that means I also have secant because they're reciprocals. So that means I would just do the reciprocal of that over here. So that would be 2 over root 3, but of course I can't leave it like that, so I end up with 2 root 3 over 3. But that means I also have other boxes. Who's the same as cosine of 30? Sine of 60. So this sine of 60 must also be root 3 over 2. And its reciprocal, cosecant, would have to be the 2 root 3 over 3. And then if I do tangent of 30, I should be able to get these 4 boxes. And then I'll at least have those 2 rows done completely. Okay, tangent of 30 would be opposite over adjacent. So that would be x over x root 3. Which, if I cancel out those x's, gets me 1 over root 3. But of course I can't leave it like that. Wouldn't that be root 3 over 3? And then I could get cotangent, right? Because they're just reciprocals. Now, helpful hint, don't do the reciprocal of this one because that just puts a square root back in my denominator. This was the same thing. Take the reciprocal of that one, and that just leaves me with root 3. Much easier. Less math for me to do. And so tell me, if who's the same as tangent of 30? Cotangent of 60. So this one's got to be root 3 over 3, which means that this guy's got to be root 3. Well, how about that? See, you didn't even have to do any math to figure out the whole row of 60 because you get to use cofunctions. Cut your work in half. Now, 45, I don't get quite so lucky, but I can still just do my reciprocal pairs. So let's quickly look at sine of 45. Now, which one are you going to choose? It doesn't matter. Either of the 45s. Opposite over hypotenuse would be x over x root 2. So simplify that. You get 1 over root 2. Simplify that. Root 2 over 2. So that's going to be the same as, or no, I'm sorry, I take that back. Take the reciprocal of that, and that gets me cosecant, right? So don't take the reciprocal of that, take the reciprocal of that. So cosecant is just root 2. Well, that wasn't so bad. When you go to do cosine, though, do you even have to do any more math? You don't. You can go back and do adjacent over hypotenuse, but by golly, guys, look. Adjacent over hypotenuse. Isn't that the exact same thing that I just did? X over x root 2? Yes! Because these two, sine and cosine, are a cofunction pair, and 45 and 45 are complementary. It's the same thing. So this is just the root 2 over 2, which means that secant is just root 2. And then tangent and cotangent are easy because tangent is just opposite over adjacent, and that is just 1. And the reciprocal of 1 is just 1. Wow. All right. What a perfect time to stop for lunch.